Hello student. Today I am going to teach the topic cloud application from chapter cloud services. Let's proceed with the topic cloud application. As a cloud application is an application program that functions or executes in the cloud. The application can exhibit some characteristics of pure desktop application and some characteristics of pure web-based applications. A desktop application resides entirely on a single device at the user's location. So it does not necessarily have to be a desktop computer. And on other hand, a web application is stored entirely on a remote server and is delivered over internet through browser interface, and that you can use in any gadget. Like desktop application, cloud applications can provide fast responsiveness and can work offline. Like a web application, cloud applications need not permanently reside on the local device, but they can easily updated online. Cloud applications are therefore under users' constant control, yet they need not always consume storage space on the user's computer or communication devices. Assuming that the user has reasonably fast internet connection device. So a well-written cloud application offers all the interactivity of desktop application along with the portability of a web application. Then a cloud application can be used with a web browser connected to the internet. Now, it is possible for the user interface portion of application to exist on the local device and for the user to cache data locally, enabling offline mode when desired. Also, a cloud application, unlike a web app, can be used in any sensitive situation where wireless devices connectivity are not allowed. That is, even when no internet connection is available for some period. Now, an example of this cloud application is varies from various sectors, like use cases of cloud applications. It's for the scientific applications, it's for the geoscience, it's for the business and consumer applications, it's for a productivity, it's for a social networking sector, it's for the media application, and also applications for cloud available in a multiplayer online gaming. Let's proceed with every sector, every areas. Now, in a scientific applications are sector that is increasingly using cloud computing systems and technology. The immediate benefit seen by researchers and academics is the potentially infinite availability of computing resources and storage at a sustainable prices if compared to a complete in-house deployment. Cloud computing systems meet the needs of different type of applications in the scientific domain, that is a high performance computing, which is shortly called as a HPC. Then also having the high throughput computing, that is HTC application, and data intensive application. The opportunity for using cloud resources is even more appealing since minimal changes need to be done to existing application in order to leverage the cloud resources. Now, in terms of the areas as in scientific application, we have healthcare management. In this, ECG analysis in a cloud, it's one of the good example that nowadays present in the cloud computing. So healthcare is a domain where computer technology has found several and diverse applications, from supporting the business functions to assisting scientists in developing solutions to the cure the disease. An important application is the use of cloud technology for supporting doctors in providing more effective diagnostic process. So in a particular, we discuss electrocardiogram ECG data analysis on the cloud. So that is one of the tool utilized for the healthcare system or healthcare sector. As cloud computing is applicable in the biology, this is the protein structure prediction. Here, application in biology often require high computing capabilities and often operate on large data set that causes extensive input-output operations. Because of these requirements, they have often made extensive use of supercomputing and cluster computing infrastructure. Similar capability can be leveraged on demand by using cloud computing technologies in more dynamic fashion, thus opening new opportunity for bioinformatics application. So cloud computing nowadays expanding their areas in the biological sector. From that protein structure prediction, here the protein structure prediction is a computationally intensive task fundamental for different type of research in the life sciences. Among this is the design of new drugs for the treatment of diseases. The geometrical structure of a protein cannot be directly inferred from the sequence of gains that compose its structure, but it is result of complex computations aimed at identifying the structure that minimizes the required energy. So basically for the protein structure prediction, cloud tools are implemented. This task requires the investigation of a space with a massive number of states and consequently creating a large number of computationals for each of these states. The computational power required for a protein structure prediction can now be acquired on demand without owning a cluster or doing all the bureaucracy for getting access to parallel and distributed computing facility. Cloud computing grants the access to such capacity on a pay per use basis, as cloud computing services follow the one structure as a pay as you go scheme. As these applications are also available in or applicable for the geoscience sector in terms of the satellite image processing. As we know the concept of how image has been processed, for that there is a concept of scalars and vectors. They are basically used in the image processing concepts. As any image has been captured, that has been divided into a number of scalars, number of parts, and that part, every part gets stored in the various locations of the memory. Here geoscience application collect, produce and analyze massive amount of geospatial and non-spatial data. As the technology progresses and our planet becomes more instrumented, that is through the development of sensors and satellites for monitoring, the volume of data that need to be processed increased significantly. In particular, the geographical information system, that is called as a GIS, is major element of a geoscience application. And GIS application capture, store, manipulate, analyze, manage, present all type of geographical reference data. Nowadays you can also found these things in number of geo laboratories where some satellite related R&Ds are going on. So this type of information is now becoming increasingly relevant to a wide variety of applications domain, from advanced farming to a civil security and also natural resources management. As a result of this, a considerable amount of geo reference data is ingested into a computer systems for a further processing and analysis. Cloud computing is an attractive option for executing these demanding tasks and extracting meaningful information to supporting decision maker. So those who are work with a geoscience sector as a satellite image processing or image processing kind of work, where these cloud computing applications have been implemented. Also, we are having the different kinds of SaaS application provides as a collection of services for such geocode generations and data visualization. At the platform as a service level, Aneka controls the input of data into a virtualized infrastructure and the execution of image processing tasks that proceed desired outcome from the raw satellite images. As I told you, every images has been captured and that gets divided with the concept of scalars and vectors. Here, the platform leverage a Zen private cloud and Aneka technology to dynamically provision the required resources. It's one of the example those who are acting in this geoscience and image processing on demand. Also, this is some pictorial presentation where you can see that as these are the satellites moving on world, on a globe, as they are going to capture the number of images, and that images has going to send to this capturing dish and antennas, where that is going to store in a local store. After all, whereas database is going to increase, number of files images has been increased, that is going to archiving. And as the different cloud computing tool like a Zen server as well as Aneka software, they are going to distribute in terms of the platform, that is an public cloud as well as a software as a service. Here in the software as a service, you can view the Google Earth number of times, where you can view the specific areas and all. Also as a public cloud, they are going to send for the Amazon web services for further filtration or further refinement. So here, how the cloud computing or cloud application has been implemented for a geoscience, it has been clearly viewed. With this, having another sector like an business and consumer application. Let's talk about this one. The business and consumer sector is the one that probably benefit the most from cloud computing technology. Number of businesses nowadays or enterprises, they go for the private cloud or hybrid cloud also. On the on one hand, the opportunity of transforming capital cost into a operational cost makes cloud an attractive option for all enterprises that are in IT centric. On the other hand, the sense of ubiquity that cloud offers for accessing the data and services makes it interesting for end user as well. Also, moreover, the elastic nature of cloud technology does not require huge upfront investment, thus allowing new ideas to be quickly translated into products and services that can comfortably grow with the demand. As a business and consumer applications point of view, the combination of all these elements has made cloud computing that prefer technology for a wide range of applications, from customer relationship management, that is a CRM app, towards enterprise resource planning systems, to productivity and social networking application, as this is applicable for the business and consumers application. With this, as the productivity comes out here, the productivity applications replicate in the cloud some of the most common tasks that we are used to perform on our desktop, from document storage to office automation and complete desktop environment hosted in the cloud. For that, we are going to use Dropbox, iCloud, Google Docs is one of the best example for that, and cloud desktop, iOS or XiOS 3. So basically, number of times, if you are not having any word processing tools from your side, simply you can use such kind of software as a service, that is in Google Docs or Dropbox kinds of cloud for the storage and the word processing system. So this is a application for the productivity. With this, we can say that there is a implementation of cloud computing for the social networking sectors. And how nowadays each and everyone from this globe gets connected with each other with the help of number of social media portals like on Facebook, Twitter, Instagram, etc. So social networking applications have considerably grown in a last year to become the most active sites on the web. In order to sustain their traffic to serve millions of users seamlessly, services like Twitter or Facebook have leveraged the cloud computing technology. The possibility of continuously adding capacity while systems are running is the most attractive features for social networks, which constantly increase their user base. As I'm talking about the social networking, where you can say there are millions of users who got connected on this different social media portal, then definitely one question arises that there is issue of network traffic, of course, but with the help of this cloud computing services, it's one of the infrastructure as a service, this issue has been resolved with the one of the parameter which is called as a load balancer. That's why you can see millions of users, they are gets connected with each other with this social media portal. They can upload the different multimedia files, photos, videos, they can share the data, but you cannot find anytime 1 or 2 hour that social media portal is going to down or that is going to idle. See, as they are properly implemented the cloud computing, so nowadays cloud computing applications are developed specifically for the social networking sectors also. With this, we have example of a Facebook. So here the development of services is facilitated by a set of tools internally developed. One of the core element is a thrift. So this is a collection of abstractions and language binding that allow cross language development. So here you can see that Facebook app is available for the various regions, various countries, various states as per their language compatibility. Thrift allows services developed in a different languages to communicate and exchange data. Bindings for a thrift in a different language take care of data serialization and deserialization, communication, and client and server boilerplate code. Then this simplifies the work of the developers that can quickly prototype service and leverage existing one. Other relevant services and tools are Scribe, where you can see number of documents gets uploaded on script and all. Whenever you want, you can download it. Also, you can upload your own data, which aggregates streaming long feeds and applications for alerting and monitoring. So this is example which tells us that how the in a Facebook cloud application or cloud services are implemented. As point of view of the media application sectors, here the media applications are a niche that has taken considerable advantages from leveraging cloud computing technologies. In particular, video processing operations such as encoding, transcoding, compositions, rendering are good candidates for cloud-based environment. Then these are computationally intensive tasks that can be easily offloaded to a cloud computing infrastructure. If you go a few years back, whenever there was a not implementation of a cloud computing, in that case, if you want to edit any kind of video, you require the special editing software for that one. Then it will take a time to upload your video or multimedia file. Once that file gets uploaded, again for the editing and all timing you need to set. So for every operations related with the multimedia operations and all, like an transcoding or composition or rendering, it will take a lot of time. But nowadays you can see, as in terms of the cloud services, they are become fast, they are available in a software as a service, platform as a service, and infrastructure as a service. Now you can easily upload the things, the multimedia which created by you or generated by you. Then also you can do various kinds of operation like an video processing, encoding, transcoding, composition, rendering very fastly, and you will get an desired expected result with the help of this cloud computing application or cloud based application. That's why these are computationally intensive tasks that can be easily uploaded to the cloud computing infrastructure. As a cloud computing can be used with a web browser connected to the internet. Now, it is possible for the user interface portion of application to exist on local device and for user to cache the data locally. See, here the data used in any sensitive situation where wireless devices also exist, and an example of cloud application is a web-based email like an Gmail, Yahoo Mail, and other kind of mail services. In this application, the user of email uses the cloud. That is, all of the emails in their inbox are stored on servers and at a remote location at the email service providers. However, there are many other services that use cloud in a different ways. Here is a yet another example like an Dropbox is a cloud storage service that lets us easily store shares files with other people and access files from a mobile device as well as your tablet as well as your laptop. So this is a applications of a cloud in the various sectors like an media applications, like an bio sector, like an what you can say social networking. So these are the various application of the cloud computing. Thank you.